as if it were a machine. We say that initially this cost $20,000 for the automobile. And let's say you could sell it now. This was the initial investment. The market value is $20,000. Oops, sorry, $10,000. Well, and during that time, you spent $5,000 on repairs. The thing that we're concerned with now is, so you had a total really of $20,000 plus $5,000 invested, but the market value is only $10,000. This is what we're concerned with. The $20,000 plus the $5,000 is $25,000 is what you have in the car, but you can only get $10,000 for it. This is what we call sunk cost. And sunk cost is cost that we can't recover. It's money. There's some emotional value attached to it. The fact that you paid this much and you can only get $10,000 even though you put $5,000 in. Okay, this is lecture number 11. So there's some emotional value, and it's hard for you to get rid of it, but it's what we call sunk cost. We forget about it. In other words, anything that's happened, the only thing that's relevant in terms of this Defender right now is that I can sell it for $10,000. What I paid for it, the repairs I did on it, don't matter. Okay? They're what we call sunk cost. Now, there's two replacement decisions we could make. One is called the cash flow approach. We can treat the proceeds from the sale of the old car, the old machine, as a down payment towards purchasing. This is lecture number 11. This approach is meaningful when both
talk about projects.
The same service.
We're moving from some
an
fundamental.
automobile, for example, wouldn't be. It would because the surface life of the life of the new machine would be longer than the old machine, we would expect. The other way to look at it is called the opportunity cost approach, and we treat this as the investment required to keep the old machine, so that the old machine, in order to keep it, we give up the opportunity to sell it for $10,000. Okay, so we're going to look at both approaches. And the one we normally use
This lecture is on
opportunity cost.
multiples.
Now, the real difference in replacement analysis is that we have a Defender, a used machine. And unlike other machines, we can't use continuous replacement analysis because it's an old machine. We can't buy another old machine. So once we retire the old machine, we can't do anything with it. So here's an example. It's the market price is $10,000. The remaining useful life is 3 years. The salvage value at the end of 3 more years is going to be $2,500, and it costs $8,000 a year to operate. And the Challenger costs $15,000, has a useful life of 3 years. The salvage value, so let me just write those down. So this is the Defender. It has a market value of $10,000. That's at the present time. And has a salvage value of $2,500, and that's at year 3. And the operating $8,000 a year. The Challenger has a cost of $15,000. It has an operating and maintenance cost of $6,000 and a salvage value of $55,000. So that's the two machines. Now, if we look at the replacement, if we use the cash flow approach, then the Defender just has $8,000. And we consider the cash we receive, so we have $15,000 is what it costs, but we take the money from so that the $10,000 we apply towards the new machine. This is the cash approach. Okay, this is lecture number 15 on rate of return analysis, another method to evaluate projects. If we look at this, then we have just, here we have P is $8,000 times P given A for I in 3. P given F for I in 3. The signs here, when we're dealing with this, we're usually dealing with the cost. So the annual equivalent cost is going to be a positive number, but it's lecture number 15 on rate of return. The signs the way they are. And here for this one, we have minus 15,000 plus 10,000 minus 6,000 P given A for I and N plus. Hey, this is lecture number 11. Okay. And so, and then the annual cost is that times A given P. So the annual cost, the annual equivalent cost at 12%, and you can work this out if you want, but it's $72.59. Again, that's a cost. And the annual cost for the second one is $64.51. So this is lecture number 11. The Challenger is less than the annual cost. This is lecture number 11. So we would replace this old machine with this new machine because it has less annual cost. And that's what we talk about a placement now. So if you want to do this for your automobile, and these numbers may be, of course, the operating and maintenance cost is going to be a little bit high, but, well, yeah, I don't know. Per year, yeah, I guess it is. But you could do the same kind of analysis for your automobile to decide whether to buy a new one. The other way to do it is the more normal way. And this is lecture number 15 on rate of return analysis approach. And what I say here, if I'm going to keep this Defender, I have an opportunity to sell it for $10,000. Therefore, I have a cost of $10,000 if I keep it.